Hello students. This video is a continuation of previous video. In last video, we saw how to solve a linear algebraic equation by direct method. And in this video, we'll see how to solve the same linear algebraic equation by indirect method, or it is said to be iterative method. Right? So, under method, we know there are one is a Gauss elimination, other one is Gauss not, and indirect method or iterative Gauss and Gauss method. We'll see that in detail. So before going into the science, we should know what is dynamic dominant. Okay. So let us consider a set of equations, set of three equations with three unknowns. That is a1 into x plus a2 into y. Sorry, b1. We'll consider this as b1. b1 into y plus c1 into z is equals to b1. a2 into x plus b2 into y plus c2z into b2. And third equation, 3x plus b3y plus c3z is equal to b3. Okay, so this is a set of three equations. Diagonally dominant condition. But in first equation, modulus of greater than or equals to modulus of b1, modulus of b1, modulus of b2 should be greater than or equals to modulus of a2 plus modulus of c2. Modulus of c3 should be greater than or equals to modulus of a3, modulus of b3. This condition is called the diagonally dominant condition. That is, in the first equation. So, which one is the first equation in this? This is the first equation. Am I right? So, in the first equation, the coefficient of x should be greater than the other two coefficients. That is, coefficient of y and z. Right? This should be greater. And in the second equation, coefficient of y should be greater than the coefficient of x and z. And in the third equation, coefficient of z should be greater than or equal to other two coefficients. Okay, so this is called the diagonally dominant condition. For direct method, we won't verify this diagonally dominant condition, but for indirect method, we have to verify. Okay, after verifying this diagonally dominant condition only, we can proceed to solve the problem. Okay, so this is called the diagonally dominant condition. So the thing is, in the first equation, coefficient of x should be greater, and in the second equation, coefficient of y should be greater than the other two variables. The third equation, coefficient of z should be greater than the coefficient of other two variables. This is called the diagonally dominant condition, right? So as I said earlier, right? So in indirect method, there are two types. One is Gauss seidel, and another one is Gauss Jacobi. Okay, so these are the two methods for the indirect method. Okay, so the main difference between Gauss seidel and Gauss Jacobi is Gauss seidel converges faster while comparing to Gauss Jacobi. For the same problem, we can solve Gauss seidel as well as Gauss Jacobi. Okay, so same, we'll be getting the same answer only. Here is slightly different. Okay, so in Gauss Jacobi, we used to assume all the variables to be equal to 0 as the initial value. Okay, so in Gauss Jacobi, what we used to do, we used to consider all the variables x naught, y naught, and z naught is equal to 0 as the initial value, and we'll start the iteration. So it is an iterative method. So the name itself indicates direct method, or it is said to be iterative method. Yeah. So iterative method, it is having iteration. So in iteration, we need initial value. So initial value, what we used to do is in Jacobi, we will consider x naught, y naught, z naught equal to 0 and we'll start the first iteration. After the first iteration, we'll substitute the value of first iteration in the second iteration and second iteration value in the third iteration value in the fourth, and it goes like that up to where we have to stop is system iteration should get saved. Okay, so that is the ending point for this method. And in Gauss seidel, what we used to do is we used to consider y naught and z naught is equal to 0, right? So in Gauss seidel, we used to consider y naught and z naught is equal to 0. We used to assume this as value and this is the iteration. After starting the iteration, very first thing will be the of x value. Okay, so the first iteration itself will be substituting the x value. Okay, so the difference between these two is in Gauss Jacobi, iteration to iteration. Okay, so iteration to iteration. Jacobi we used to do what we used to do is iteration of the value on the iteration is Jacobi. But in C, what we used to do is values of the iteration substitute. Right? So substituting y naught and z naught equal to 0, we'll be finding x1 and we'll be using x1 in the first iteration itself. So first iteration in the x value, after finding one, will be these two values to find z. Okay, so using the initial values. So values we used to substitute. Right? So that is the difference between Gauss seidel and Gauss Jacobi method. That's why seidel converges faster comparing to Jacobi. Okay, so Jacobi iteration to iteration substitute பண்ணுவோம். Seidel iteration குள்ளே we used to substitute. So that's why seidel converges faster. Okay, so this is the basic thing you should know about the Gauss seidel and Gauss Jacobi. That is the concept. So now we'll try to solve some problem under this. So first we'll see problem under seidel method. Example. So first example is 27x 6y minus z equals to 83. Second one, plus y plus 54z is equal to 110. Third equation, 6x plus 15y plus 3z to 22. Okay, so we are going to solve this by Gauss seidel method. So whatever the method may be, either it is Gauss Jacobi or Gauss seidel, very first thing what we have to do is we have to check the diagonally dominant condition. So what do you mean by diagonally dominant condition? In the first equation, coefficient of x should be greater. In the second equation, coefficient of y should be greater, and in the third equation, coefficient of z should be greater. If suppose if not, and the Mari condition satisfy agalana, we can rearrange the equation. Right? Okay. Suppose diagonal dominant condition satisfy agala appadina, we can rearrange the equation and we can make it into proper form and then we have to proceed the iteration. Okay. Just look at these three equations. In the first equation, it is in proper form. Coefficient of x is greater than the other two. But look these two equations. So in the third equation, z oda coefficient of பெருசா இருக்கு, and in the second equation, coefficient of z is bigger than these two, and in the third equation, coefficient of y is greater than the other two. So now what I'm going to do is I'm going to rearrange these two equations. ஓகேவா? இப்போ நம்மளோட இதுபடி செகண்ட் ஈக்குவேஷன்ல ஒய்யோட கோஎஃபிஷியன்ட் பெருசா இருக்கணும், தேர்ட் ஈக்குவேஷன்ல ஜெட்டோட கோஎஃபிஷியன்ட் பெருசா இருக்கணும். பட் ஹியர் தட் இஸ் நாட் தி கேஸ். So what we are going to do is we are going to rearrange these two equations. Okay. So solution, since it is not in proper form, so we will rearrange this equation. 27x plus 6y minus z is equals to 85. 6x plus 15y plus 2z is equals to 72. X plus y plus 54z is 103. Okay. Right. So now this is in the under proper form. Just look at the first equation. This is greater. In the second equation, this is greater. In the third equation, this is greater. So if you want, you can mark this Like this is for our understanding. Okay. So next, what we have to do is using these equations, we are going to find a new equation for x, y, and z. Okay, that is from the first equation we can find one equation for x. From the second equation we can find one equation for y. From the third equation we can find one equation for z. Okay, so from this equation x is equal to, or we can keep like this: 27x is equal to. Take the other two to the other side. So 85 minus 6y plus z. So from here, x is equal to 1 by 27, 85 minus 6y plus z. So the equation for x. So in a similar way, we can find an equation for y and z also. So what is the y equation? 15y is equal to 15y is equal to 22 minus 6 2z இல்லையா minus 6x minus 2z. So y will be equal to 1 by 15 72 minus 6x minus 2z. So next is z. 54z is equal to 54z is equal to 110 minus x minus 5 minus x minus 5. So z is equal to 1 by 54 into 110 minus x minus 5. Okay. So this is the equation for x. This is the equation for y. This is the equation for z. Now to start the iteration, I am going to consider these three equations. Okay, since it is a Gauss seidel method, the initial values will be equal to y naught is equal to 0 and z naught is equal to 0. Okay, so Gauss seidel, we won't take the 3 to be equal to 0. Instead, we will be considering y and z is equal to 0. Okay, we'll find the value of x and substitute in the iteration itself, first iteration. Okay, so let's name a tablet column for this. So what will be your x equation? 1 by 27 x n plus 1 is equal to 1 by 27 85 minus 6 yn plus zn. Okay, so this is for x, and y n plus 1 is equal to 1 by 15 72. Here I am using the x value. So minus 6 times of x n plus 1 and minus 2 times of zn. In means, see, ஏன் நான் x n plus ஓகேனா என்னோட ஃபர்ஸ்ட் ஐட்ரேஷன் வேல்யூவோட ஃபர்ஸ்ட் ஐட்ரேஷன்ல உள்ள எக்ஸோட வேல்யூ தான் ஐம் கோயிங் டு சப்ஸ்டிட்யூட். அதனால தான் எக்ஸ் என் பிளஸ் ஒன் எழுதியிருக்கேன். ஓகேவா? ஸோ சின்ஸ் தேர் இஸ் நோ பிளேஸ், ஐம் கோயிங் டு டிவைட் அண்ட் ஐம் கோயிங் டு ரைட் திஸ் ஹியர். Z n plus 1 will be equal to 1 by 54 110 minus x n plus 1 minus y n plus. Okay, right? So now we can start the iteration. Okay, put n is equal to 0. So n is equal to 0 substitute பண்ணும்போது what will be getting here? Put n is equal to 0 first. For all the three, put n is equal to 0. So x1 is equal to 1 by 27 into 85 minus 6y0 plus z0. Okay, and y0 and z0 we know, we have considered here. Yeah? Y0 and z0 that is equal to 0. So now substitute. So if you substitute 0, we are getting 85 divided by 27. Normally for seidel and Jacobi in calculator, we can fix the decimal places in 4 decimal places so that the accuracy will be maintained. Other calculator decimal fix. Okay, so these two will be equal to 0 by 27. So our x value will be 0.148. x1 value. Okay. So next comes y1. So y1 is 1 by 50. 6 of y1. 2. Okay. So we are substituting also. So it's 0 here also. Be 1 by 50, 72 minus 6 times of y1 and 2 times of z0, right? So here, sorry, it's not y1, it is x1. Sorry, it is x1. So now we'll substitute this value here. And we know z0 is equal to 0. So z0 and x1 1482. So our y1 will be equal to 3.540. Okay. Next come to the next one, z. Again put n is equal to 0 here also. So z1 is equal to 1 by 54 into 110 minus x1 minus y1. 110 minus x1 minus y1. So here we know the value of x1 and y1. And the first iteration வந்து x1 value கிடைச்சிருச்சு. இது பாருங்க previous stepல y1 value கிடைச்சிருச்சு. So now we are going to substitute this x1 and y1 value to find the value of z1. So z substitute பண்ணும்போது we will get z1 is equal to 1.9182. This is the value of z1. Right? So next, second iteration. So for second iteration, put n is equal to 1 now. So if n is equal to here, so x2 is equal to 1 by 27 into 85 minus 6 times of y1 plus z1. So we know y1 and z1 value. So using calculator, we can and we can find the value of x2 to be equal to 2.4322. Okay, and y2 is equal to, now substitute n is equal to 1. So if you put n is equal to 1, this will be equal to 1 by 15, 72 minus 6 times of x2 minus 2 times of z1. So in the equation, n is equal to 0 substitute பண்ணுங்க in the general equation. In the general equation, and you have to substitute n equal to 0, n is equal to 1, n is equal to 2, and so on. And when we have to stop the iteration, render successive iteration, you should be okay. So the value of x2. X2 we know, so we can substitute here z1 from the previous value iteration we can take. So our y2 will be equal to 6.5722. Similarly, put n is equal to 1 in z. So z2 is equal to 1 by 54, 110 minus x2 minus y2. We know the value of x2 and y2. So substitute it. So z2 will be equals to 1.9258. Okay. So we have to see like next put n is equal to n is equal to t, like that it goes up to the two the same value வருதோ அது வரைக்கும் you have to put. Next I am going to n is equal to 2. So n is equals to 2, our 3 will be equal to 2.457. y3 will be equal to 3.5729, and z3 is equal to 1.9259. Okay, so this is the value. Then substitute n is equal to 3. Next, n is equal to 3. So if you put n is equals to 3, you will be getting x4 is equal to 2.425, y4 is equal to 3.570, and z3 is equal to 1.9259. Okay, so now this is correct. 1.9259 and 1.9259. But look, x and y value, we are getting a slight variation. That is in the fourth position. Okay, so we'll do one more iteration. N is equals to 4. If you put n is equal to 4, you'll be getting the same value. And y4 is equal to 5730. And z4, so z5 is equal to 1.925. Okay, so iteration for 4 and 5. So this is your first, this is your second iteration. This is 4 and this is okay. So iteration 4 and 5 are similar. Values of iteration 4 and 5 are similar. So we can check the iteration and we can say the value 2.4259, the value of y 3.5130, and this 1.259. Okay. So this is the condition. First is the condition, and then we have to find the equation for x, y, and z. We have to proceed the iterations one by one by substituting n equal to 0, 3 like that. And where we have to stop, 2 successive iterations should get the same answer. From these two, x oda value 2.4259, y oda value 3.5730, and z oda value 1.925. Okay, so this is the answer. Okay, right? So once again we'll go through. The very first thing what we have to do is, for both Jacobi as well as seidel, the diagonally dominant condition. Okay, so first we have to check the diagonally dominant condition. If diagonally dominant condition is verified, then you can start the iteration. If suppose it is satisfied, so just look at these two equations. Okay, look at these two equations. Diagonally dominant condition is not satisfied. So in that case, what we can do is we can rearrange the equation. That is, we rearrange and again we have to check whether it satisfies the diagonally dominant condition. If it satisfies the diagonally dominant condition, from that we have to find an equation for x, an equation for y, an equation for z. So after verifying the diagonally dominant condition, we can find the equation for x, y, and z. Now equation is ready to start the iteration. So as said earlier, for seidel method, we have to y and z equal to 0. We have to find the x, and then we have to substitute in the iteration. Okay. So for seidel, let us consider y and z equal to, and we can start the iteration. And there we have 2 successive iterations should get the same answer. Then you can stop the equation. Okay. So next we see one example for. So next we'll see one example for Jacobi method. So Jacobi method is also similar to the seidel method only. The only main difference is iteration to iteration. seidel வந்து iteration குள்ளே நம்ம substitute பண்ணுவோம். ஆனா இங்க வந்து iteration to iteration. So we'll see one example for that. Example 20x plus y minus 2z is equal to 3x plus 20y minus z is equal to minus 18. 2x minus 3y plus 20z is equal to 25. So we have to check the diagonally dominant condition. Just look at these 3 equations. So in the first equation, coefficient of x is greater, and in second equation, coefficient of y is greater, and in third equation, coefficient of z is greater. So now it satisfies dominant condition. So next, what we have to do, we have to find one equation for x. From the first equation, find an equation for x. From the second equation, find an equation for y. And from the third equation, find an equation for z. Okay. So from this, x is equal to 1 by 20, 17 minus y plus 2z. And y is equal to 1 by 20 minus 8 minus 3x plus z. And z is equal to 1 by 20 25 minus 2x plus 3 times of y. Okay. So here for Jacobi, initial values are x is equal to 0, y equal to 0, z equal to 0. So we'll be considering all the three equals to 0 because இது நம்ம என்ன பண்ணுவோம் iteration to iteration தான் substitute பண்ணுவோம். So no problem. So நம்ம என்ன பண்ணிக்கலாம் all the three to be equal to 0 consider பண்ணிக்கலாம். So now we'll frame the equation in general. X n plus 1 is equal to 1 by 20, 17 minus yn plus 2 times of zn. Yn plus 1 is equal to 1 by 20 minus 18 minus 3 times of xn plus zn, and zn plus 1 is equal to 1 by 20 25 minus 2 times of xn plus 3 times of yn. Okay, right? So now we can start the iteration. Put n is equal to 0 first. So if you put n is equal to 0, x1 is equal to 1 by 20 into 17 minus y0 plus 2 times of z0. These two are the initial values, so that is equal to 0. So 17 divided by 20, our x1 will be equal to 0.8500. So now for this, I am two decimal places. So two decimal places in the 2 or 3. You may mention Pandalana, we can keep it as 4 decimal places, otherwise we can round out it to 2. So here we'll take 4 itself, no problem. Next, y1 is equal to 1 by 20 minus 18 minus 3 times of x0 plus z0. So minus 18 divided by 20, so minus 0.903. Okay, z1 is equal to 1 by 20, 25 minus 2 times of x0 plus 3 times of y1. So z1 is equal to 1.2500. So this is the first iteration. Okay. So next, put n is equal to 1. If you put n is equal to 1, you will be getting x2 value. So x2 is equal to 1 by 20, 17 minus y1 plus 2 times of z1. So now what we are going to do is we are going to substitute the first iteration value in the second iteration value in the third iteration. Like that it goes. Okay. So our x2 is equal to 1.0200. y2 is equal to 1 by 20 minus 18 minus 3 times of x1 plus z1. So y2, this is x2. So y2 is equal to minus 0.9650. And similarly, z2, so 1 by 20 into 25 minus 2 times of x1 plus 3 times of y1. So z2 value will be equal to 1.0300. So you have to proceed like this. Put n is equal to 2. So if you put n is equal to 2, you will be getting x3 1.0010, y3 minus 1.0020, x3 1.0030. Next, put n is equal to 3. So if you put n is equal to 3, x4 you will be getting 1.0000, y4 equals to minus 1.0000, and z4 is equal to 1.0000. And finally, x5, that is n is equal to 4. If you substitute n is equal to 4, you will be getting x5. So that is also equal to 1, y5 minus 1, and z5, it is 1. Okay. Now look at the fourth and the fifth iteration. Both the values are same for all the three variables. Yeah. X value and y. Y value minus 1 and z value 1. So now we can start the iteration. See, without calculator we cannot do anything. For example, you have to bring calculator. Calculator இல்லனா நம்மளால iterations போட முடியாது. கண்டிப்பா calculator தேவை. ஓகேவா? So calculatorல ஸ்பீடா போடுறதுக்கு பழகிக்கோங்க. Right? ஸோ கால்குலேட்டர் யூஸ் பண்ணி தான் இந்த கால்குலேஷன்ஸ் எல்லாமே போட முடியும். ஓகேவா? ஸோ அதை ஞாபகம் வச்சுக்கோங்க. ஸோ நவ் we can stop the iteration and we can say that therefore x is equal to 1.000, y is equal to minus 1.000, and z is equal to 1.0000. Okay, or you can say x equal to 1, y equal to minus 1, and z is equal to 1. So this is the answer. Okay. So in this video, we have seen two methods under indirect methods or iterative methods. Okay. So one is Gauss seidel, another one is Gauss Jacobi. So seidel, what we used to do? Iteration குள்ளேயே நம்ம values கண்டுபிடிக்க we used to substitute. And Jacobi, iteration to iteration we used to substitute. So that is the difference between seidel and Gauss Jacobi. And Gauss seidel surges faster while compared to முதல்ல வேல்யூ அதனால தான் Gauss seidel converges. Okay. Thank you.